One. If I told y'all to do part E yesterday on your own to try it, today we're going over it. Oh, yeah. So we have for the first time on part E, we have a quotient. We have a quotient of two polynomials. So can we use our skill of, thank you, can we use our skill of just doing it for plain old polynomials and transfer that into a quotient of polynomials? Sure, I would hope so. These are all transferable skills you're learning here in New Braunfels High School. Okay? You're you're learning hard skills and you're learning soft skills. All right. Well, let's go ahead and look at it and say, do we think that this is even or odd or neither to begin with? Neither? Okay. Any other guesses? Even. All right. Any other guesses? Odd. Okay. So we've got some people. Even, odd, and neither. Well, it's going to be one of those. So y'all are a good class. Y'all are among the best guessers out there. Right? Because someone's going to be right. Yeah. By the way, that's on page 35 of 838 Ways to Amuse a Child. Yeah. No. It's no. It just says take a survey and laugh with them. Yeah. No, I'm kidding. I made that up. I was telling someone that when I got it, I thought it was 838 ways to abuse a child. Right. Yeah. I said that to y'all. Yeah. And then I started reading it, and it was like, no, it's actually 838 ways to abuse a parent or a caretaker, right? Or a babysitter, right? Having to amuse a child, that's abuse. I don't know. But still, no one has checked out or offered to check out the How to Be a Better Student book, so it's still available. It's an old one, yeah. No, no, no. All right, here we go. The test. R of negative M. There's on my website. There is a survival. How to survive pre-cal. We always do the test that way. We replace M with negative M or X with negative X because we want to see what happens in the other realm when we're horizontally the same distance away. And now we plug it in and we get negative M to the third power all over 3 minus 2 times negative M squared. And then we simplify, okay? A negative M cubed, well, that's the same as negative M cubed. Because negative times negative is positive, positive times negative is negative. So anytime you have a negative to an odd power, you can essentially drop the parentheses, which is it's really pulling the negative out front. That's what it's really doing. Okay? And then in the bottom, we get 3 minus 2, and then negative M quantity squared. Well, that's an even number. So now the negative goes away, and we get no change. So we compare this to the original, and we're like, is it the same? No. No, it's not the same. Is it the opposite of the same? What would opposite of the same look like? Oh, okay. Yeah. Well, let's see. The negative m in the top, that's really a negative 1 times m cubed. I can bring that negative out front if I want. Just like if there were a 5 there, I could bring the 5 out front. So I could write this as negative m cubed all over 3 minus 2m squared. Right? It's just like if I have like x over 5, I could call that 1/5 x. It's like kicking the x off to the other side, not the left side, but the right side. Okay? So if I bring it to the bottom, if I write it too low, now I bring it to the bottom, now I have to distribute it because there's 2 terms down there, or leave it factored. Okay? But because it's a factor, I can bring it out front. And now, if I put parentheses in there, look what we have inside here. Is that the same as what we started with? Yes. So then I can replace what's inside the parentheses with R of M. And look what we just did. We just said that R of negative M is equal to negative R of M, which means we got ourselves a what type of function? An even? An odd. What did she say? You said odd? I didn't hear. Odd. An odd function. Yes. Not an odd function. An odd function. Not a nod function. A nod function is part neither, part odd. Yeah. Did you not say odd? No, you did not say nod. I heard nod. Yeah. Did you say odd too? Well, you guessed odd. Or you knew odd. Thank you. Thank you. Yeah, it is an odd function. So here's what we're going to do now. We're going to backtrack and say, well, how in the heck could I determine from the beginning now, just at a glance, that it was an odd function? Okay? Because that's really what we're earning towards. We're learning how to do arguments here. We're learning how to do these are called like proofs essentially. We're learning how to formulate arguments, mathematical arguments. But we also want to develop our insight, right, into things. So let's see, the top. The top is m cubed. If I just had m cubed by itself, would m cubed be an even, odd, or neither function? It would be odd, right? Because there's only one variable. So I plug in one time and I get m to the third power, which is an odd number, and that's going to make that term change signs. So yeah, the top is an odd function. So let's go. I'm going to write over here. This is an odd function divided by 3 minus 2m squared. If I were just looking at that one by itself, would that bottom function be even, odd, or neither? And don't say neven. Even. Good. Even, not neven. Even, because there's only one variable, it's to an even power, so you plug it in, it's going to stay the same. So the bottom is an even. So I had an odd function divided by an even function, and it ended up being an odd function. Is there anything to that? That's the distillation of what the process is. Now, we have to make sense of that. Is that even worth commenting on? That in this case, an odd function divided by an even was odd? Probably. We don't know yet, though. So let's look at more data. We need more data. More data. Letter F. Look at this guy. Q of Z. Let's see. Let's kind of put our new little insight to the test here. If I were looking at just the top, the numerator, would that function itself be even, odd, or neither? 3 terms, all variables, odd exponent, odd exponent, odd exponent, change, change, change. That is odd. Yeah. So the top is an odd function. Divided by the bottom. Also odd, right? Odd number, odd number. So we have an odd divided by an odd. What you think? What? How many say neither? I heard neither. Neither. How many say odd? No one say odd. How many say even? Even. Okay, it's about balance on the neither and even. So I guess we can call it an even, right? Neven and move on with it. Neven. Nod. Well, that's already a word, right? But not with 2 D's. Page 73. Make up new words with the child. No. No, we're just writing the book ourselves. Let's go ahead and see. Let's go ahead and see what it's going to be. Q of z, negative z, sorry. Q of negative z is 3 negative z to the fifth minus 6 negative z to the third plus negative z all over 3 negative z to the third plus 4 negative z. Wow, you see why we were trying to develop a different way to determine if it's even, odd, or neither, other than this? This is a little bit sometimes arduous. Now let's simplify. If we simplify, whoa, since we already know the top is odd, every sign is going to change. Negative 3z to the fifth, this is going to be plus 6z to the third, and this will be minus z. In the bottom, all the signs change. You get negative 3z to the third minus 4z. Now, if you compare that to the top, it's not the same. Yes, very good. That's what we do. We take a negative out of the top, which now changes the signs all back. Minus 6z cubed plus z. And if I were just to take the negative out of the top and bring it to the front, like we did previously, then it would have to be already the same. But it's not until I factor out a negative from the bottom as well. So I get positive 3z cubed plus 4z. And here's what happens. When the numerator is an odd function and the denominator is an odd function, what happens with those two negatives that are out front? They divide. They divide out. Divide out. They divide out. Carson, they do what? They divide out. Thank you. Everybody, they divide out. They divide out. And what we're left with is just 3z to the fifth minus 6z cubed plus z all over 3z cubed plus 4z. And now if you compare that to the original, it's the same. So now we say that this equals q of z. So q is even. So odd divided by odd is even. Yes. 35 over 7? Oh, but we're not talking about an odd number. We're talking about an odd function. And the reason an odd function divided by an odd function is even is for the same exact reason a negative divided by a negative is a what? A positive. Yeah, it's built into the same thing. Yes. Yes. Yeah. Yeah. So here, let's look at our data real quick. Odd divided by even was odd. Odd divided by odd was even. Ah, odds are like negatives, and evens are like what? Positives. And that makes sense because an odd function is the opposite of the other function. So it's a negative out front. And an even function is it's the same. So it's like having a positive 1 out front. So yeah, so now we know, oh, an odd divided by an even is odd because a negative divided by a positive is negative, right? And odd divided by odd, that would be tantamount to doing negative divided by negative, which we know is what? Positive. Yeah. Wow. We don't really need to work the rest of them. Or the next one. What happens if you have a neither, do you think? An even or not? Yes, sir. Oh, that's a good question. What would a positive divided by a positive be? Positive. So an even divided by an even is, no, it would not. It would not change. No. Hey, and guess what an even divided by an odd would be? Also an odd. Yeah. Now neither ruins the party. I'm going to skip example G, which is a neither function. Okay. Yeah, just look at the top. The top is neither, right? You got 5, 3, which is change, change, and then no change. Constants ruin origin symmetry. Yeah, if you think about that, this right here would have origin symmetry. Let's look at that. Let's just say it would look like this. Thank you. What happens if I do plus 6? It moves it up 6. Now if I try to flip my iPad upside down, that piece ends up landing down here instead of up there, right? And so it messes it up. So you can't have a vertical shift, a constant, if you will, with any type of odd function. It messes it up. So the numerator is a neither function, and the bottom is an even function, and this tends to be always neither. Okay. You could think of N as being a zero wielding an axe and a flamethrower. Yeah, he's just no flamethrowers. Oh, okay. Well, he has chemical warfare in his pouch, so that's why he has it. Yeah. Okay, so he doesn't have mustard gas, but he's carrying around ketchup gas. Yes. Let's look at example H. H, and we're going to summarize all this down below. Big F of x is. Now, we no longer have a quotient. We no longer have a quotient. But I want to show you this example because now we have a radical. And how do radicals work? How do radicals work? Can we even test to see if a function that's to an even root, like square root or fourth root or sixth root, are those going to have a chance at having symmetry? Well, how do we test? We replace x with negative x, and now we have a negative under a radical. Is that going to be okay? No, it's not going to work. So even roots don't have a shot at making they don't have a shot at making the symmetry list. But odd roots possibly can. Okay? So let's go ahead and do the test here. F of negative x equals negative 3 times the cube root of 8 times negative x. I'm just going to call that negative 8x. I think we're kind of advancing to that point. All right? Or maybe I should not. I don't want to confuse people here. Let's just do it like this. 8 times negative x. And then on the next line, I'll write that as negative 8x. Now, negatives under a radical, I know when you see them, you might like be alarmed. Ah! Because you have a lot of experience with square roots more than any other. And negatives under those are not good. Okay, unless you're talking about complex numbers. So in this case, this is the same as negative 3 times the cube root of negative 1 times 8x. And that's the same as negative 3 times the cube root of negative 1 times the cube root of 8x. This is, you see what I'm doing here? Everyone knows what I'm doing from one line to the next. I'm hoping, right? Because I'm showing every single step. I'm taking those jurors, those doubters, on this journey with me, and I'm letting them enjoy the walk, but I'm making sure they step into small little footholds that I already have created for them. Now, why would I do that? Because look at this. What is the cube root of negative 1? Negative 1. Negative 1. Okay? So, the cube root of a negative number is also a negative number. Just like the cube of a negative number that we saw earlier today is also a negative number. The cube root as well. So now I can go and change the sign in the front because I multiply by a negative 1. And now I compare that to the original. Is it the same as what I started with? No, but is it the opposite? Well, what if can I multiply this by -1 twice? Let's multiply this by -1 twice. -1 times -1. Why would I want to do that? Because I want to create a negative times possibly the function. Because if it wasn't the same up above, when it was the same, let's see if it's the opposite. Is this now big F of x, what I highlighted? Is it the same? Yes. So now I could say that this is the opposite of big F of x. Therefore, so F is what? Odd. Good. It has origin symmetry. The graph actually kind of looks something like this. It comes in like this, and then goes out like that. It's that graph right there. It has origin symmetry. Ooh, I just turned my iPad upside down, and it looked the same. Watch, look. Y'all can compare it right side by side. You can't. Yeah, it is. Yeah, it's odd, not peculiar. This one is odd and peculiar, I guess. Yeah. Okay. Now, having said that, let's see if we can answer part I on our own. And if we could do I on our own without writing it all down, we will score a touchdown, baby. A touchdown. There weren't many in the game last night on Amazon Prime. Wow. And then the Baylor game. Oh my gosh. Grab, grab, grab. No one tackled. Hey, look. What's the name of this function? I just said we were going to score a touchdown, and its name is T of D. TD, G, touchdown, G, TD, G, touchdown, G. Yeah. Yes, the Astros are up 2-0 in the division series. Yeah. They are. Jordan is he's coming in clutch. I do. Yes, I do. Yeah. What do you think the top is? Do you think the top is even, odd, or neither if it's D to the 2/3? Odd? Ah, well, yeah. What is that? I'll do this too. Is everyone on task here? TD, touchdown. TD, touchdown. Well, I'm just rewriting it. Yeah. See? So all I did is I took the 2/3 exponent and wrote it as cube root of d squared. Okay? That makes it a little bit easier to see. Now, I would suspect that it would be an odd function when I saw the cube root, right? Just like in the previous problem. However, look what we have underneath the radical, a d squared. D squared. So by the time it gets to the cube root, is it ever going to be negative if it comes out of a squared machine? No. So the numerator is actually even because of the d squared. This is an even function. And the bottom is what? Also even. Yes. And an even over an even is an even. That's right. Let's summarize. Summarize. Ready? For polynomials or for single line things. For single line things. If none of the signs change, the function is what? Even. I'm going to put a big E. If all of the signs change, the function is odd. If some signs change and some stay the same, the function is neither. Yeah. That's neither here nor there. How you pronounce neither. And then for quotients, even over even is even. And then you got the even odd combo in any order. Odd, right? Yeah. So positive over negative or negative over positive, right? It's going to be negative. An odd over an odd, even. And then a neither over a whatever or a whatever over a neither. Neither, yeah. The whatever part could be even, odd, or neither, right? It could be whatever. A neither is, what did we say earlier? He was a troll crossing a bridge illegally. All right, we got a few minutes left. Um, we're gonna stop right here, okay? So we'll pick up with example 7 in the future.